Alright, so now that you've had a chance to take a look at the homework, I am excited to show you a new lesson. Today is the 18th, and this is section 8.4. We're going to be learning about roots and zeros. But specifically, we're going to be talking about this rule called Descartes' rule of signs. And this is actually, sorry, that was my phone going off. I'll put that on silent here. You guys could all laugh, it's pretty funny. I should have put it on silent before. But anyway, what Descartes' rule of signs is it's a way to determine how many positive and how many negative roots a polynomial is going to have. It's almost like if you're going, say you're going to the beach and you left a shoe on the beach. Somebody would probably ask you, what does your shoe look like? Were there multiple shoes? And then you would go look for them. It's the same with polynomials. If you know that there's definitely two positive roots, you would look for two positive numbers. Maybe x is equal to 1 and x is equal to 3. If you know that there's no positive roots, then you wouldn't look for them. So let me show you what this rule means. What Descartes' rule of signs says is that given a polynomial p of x says two things: the number of positive roots, zeros, or x-intercepts is equal to the number of sign changes of p of x, or that number minus 2 until 0. What that means is, let's say you count the number of sign changes and you get 3. If there's 3 sign changes, the answer is going to be 3 or 1. If there's 2 sign changes, the answer is going to be 2 or 0. We always subtract 2 unless we can't do it. Like, let's say if there's 1 sign change, you can't do 1 or negative 1 because it doesn't make any sense to have a negative number of anything. This will be more clear when we take a look at examples in a little bit. The number of negative roots the way that we find this is actually, it's a little bit different. So there's something we have to do first. We change the signs of the odd powers of x. So x to the third, if it's a positive number, we treat it like a negative. If it's negative, we treat it like a positive. An even power we don't touch. And then what we do is we count the number of sign changes or subtract 2 until 0. Okay, so let me show you what this looks like. I understand it could be a little confusing right now, but math's better to explain with numbers, so let me show you an example. Say if we had a problem like this. That's my garage opening if you hear some noise in the background. But let's say you had a problem like this. If f of x was equal to, let's say x to the third plus 2x squared minus 3x minus 3. Okay? So all we're going to do is we're going to figure out the number of positive negative, and imaginary roots for this polynomial. It's not important right now to know what they are, we're just trying to figure out how many of each we should get. So let's start with total. Total is going to be 3 roots because the highest power of x is 3. The way we figure out the number of positive roots is we count the number of sign changes. So x to the third plus 2x squared minus 3x minus 3. This is a positive term. So is this. This is negative, this is negative. So it looks like there's one change, reading this from left to right. Whenever I teach this, I always say pretend like it's a mood. In 4 days, I might be in a good mood, bad mood. Well, that's a sign change right there. My mood changed from good to bad. Now let's take a look at how we figure out the number of negative sign changes, or number of negative roots. What we're going to do is we're going to take our polynomial, and we're going to change the odd powers of x. So whenever I teach this, I highlight this is odd, x to the first is odd. Some people say that I'm a little bit odd. That's a joke, you could laugh. But we're going to change those signs. So instead of being positive x to the third, we're going to pretend like it's negative. This is an even power, so we leave this sign the same. Because this term is odd, it's an odd power, we're going to make that a positive. And then negative 3 is really negative 3x to the 0, so we leave that alone. Bad mood, good mood is a change. Good mood, doesn't change. Good mood, bad mood does change. So this has 2 changes. But remember what we said before. We always subtract 2 until we get 0. So the final answer for this would be 2 or 0 negative roots. We didn't do that with 1 because you can't say 1 minus 2. That would be a negative number, and you can't have a negative number of anything. So let me show you the way I would like you to answer these. As far as our possible positive roots, negative roots, and imaginary roots, we know that there's 1 positive, and there could be 2 negative. So if we have to come up with a total of 3, there would be 0 imaginary. There could be 1 positive and no negative roots. So to get a total of 3, there could be 2 imaginary. If I see you again and we make charts, well, hopefully I see you again, but if I see you again soon, the table would be an appropriate way to answer that question. So let me maybe show you a couple more examples. What if we had a problem where p of x was equal to negative 9x to the third minus x squared plus 5x minus 8? So the total number of roots would be 3 because it's x to the third. But then when we go to find the number of positive roots, we're going to look at the sign changes. This is a negative term, this is a negative term, this is positive and negative. So negative to negative doesn't change, negative to positive changes, positive to negative changes. Those are 2 sign changes, so we say 2 or 0. We're going to do the same thing with the negative roots. But anytime we see an odd power of x, we have to change the sign. I know that this is odd, I'm a little bit odd, so we're going to change those terms to be positive. And it looks like there's only 1 sign change. So going back to our table, when we list our positive, negative, imaginary, and total, remember we said there's supposed to be 3 total roots. Well, if there's 2 positive, there's 1 negative. We have to get a total of 3, so we would have no imaginary roots in that scenario. We could also have 0 positive and 1 negative, which would give us 2 imaginary or 3 total. This would be the best answer. Okay, and last example for today would be one like this. What if we had p of x is equal to 4x to the fifth plus 3x to the fourth minus 2x to the third plus 5x squared minus 6x plus 1. This one's a little bit longer. And again, if I'm going too quickly, feel free to pause the video, and you could always watch it when you're ready. Total number of roots for this would be 5. That's the highest power of x. Number of positive roots, we look at the signs, and we always subtract 2 until we can't do that anymore. Alright, so there's a lot going on here. We read it from left to right just like a book. This looks like a sign change. Negative to positive is a sign change. Positive to negative is a sign change. Negative to positive. So we have a lot going on here. It looks like there's 4 times the sign changes. But remember what we said. We always subtract 2 until we get 0. So we would say 4, 4, 2, 4, 0. We keep subtracting 2 until we can't do it anymore. For the number of negative roots, we change the signs of the odd powers of x. So this is odd, this is odd, this is odd. We're going to change those signs. And it looks like there's only one change. When we go to make our chart, we're going to have number of positive, negative, imaginary, and total roots. Positive, there could be 4 positive and 1 negative. There could be 2 positive with 1 negative. You want to make sure you combine all the different combinations. If there's 0 positive, there might be 1 negative. Total, there's supposed to be 5. So the way that we figure out how many imaginary is how many more do we need. Well, if there's 3, there would be 2 more. 1 would give us 4. I hope that was helpful. For homework, what I would like you to do, and please submit this by 11:59 tonight, I would like you to please do on page 507. I attached pictures of the worksheet, but I would like you to please do numbers 9, 10, 18 to 24 even. And I would like you to do on practice 8-4, please do numbers 1 through 6. Alright, hope you have a nice day. Thanks for watching my lesson. If you have any questions, feel free to email, or I'd prefer if you just commented. Thank you very much.